define and use fractional exponents.
Yeah, that's why I'm not ahead, because this looked really hard.
Very simple.
That's some biting irony right there.
After I showed you. Alright, so let's just give you the main point here. Here's a root symbol. Notice I did not say square root.
How come?
You're going to find out, because it's not always square root that you're going to find. Square root means you're taking and identifying what two numbers you multiply together twice, right? That's where the square comes from, to get the number under the root, the radicating. So you could have a cube root, you could have a fourth root, fifth root, sixth root, and that number actually goes here. So in general, n, that's the letter n, represents any number, okay? Any base that you're looking for that you're multiplying that many times to get it. All right? So here is the base inside, and then also you have an exponent that it's raised to. Everything you've ever done, this has always been a 1. They've never listed it, but there's always been a 1 there. Okay? I'll show you in a minute. But this doesn't have to be in this position. It could be, let's do a little dotted line, that you perform that exponent operation last. You can either do the exponent first, or you can take the root and do the exponent last. You get to choose. That's the wonderful thing about this. Okay, now let's look at some examples so I can kind of ease you into some difficult problems. Example 1. Well, let me go back to this real quick here. What this equals is your base. I haven't calculated anything yet, okay? So I'm manipulating the way this looks. This is now raised to the m over n. Okay? So these two things are exactly the same. You can write them either way. So that's where your fractional exponent comes from. The root is always the denominator. Got it? So I put this up here just to show you where to put all the numbers when you manipulate them. All right, let's do example 1. Let's do something you all know. What is that?
4.
Excellent. Now let's evaluate it based on what we have here. This is a 2. And on your calculators, you don't ever have a 2 there because it's understood that that's what it is. It'll never be a 1 because that doesn't make any sense. Okay? So you got 2 here. And this is a 1. All right, so rewrite it like this. What is it going to look like? Raise your hand. Min.
16 to the 1. Wait, hold on. Wait, yeah, 16 to the 1/2 exponent.
That's right.
Yeah.
All right, which you all said the answer was 4 to that, which you don't ever think of 16 to the 1/2 as being 4. But I'm just going through it with you. All right. So now you kind of understand the positions. All right. Now remember, you could do 16 to the first. What is 16 to the first? 16, and then take the square root. You get 4. All right. Well, let's take the square root of 16. 4. And 4 to the first is 4. All right. So it's easy when there's ones. Let's see if it works with other numbers. So.
Okay.
Yeah.
If no matter what the square root is or whatever, if there's zeros, it's still 1.
If your exponent, if this is a 0, then that's a 0. And 0 over anything is what?
0.
And 0 is your exponent, so your answer is going to be 1. That's right. This is not going to be 0 here. That will be undefined. That's 0. Okay. Alright, example 2. 25 to the negative 3 halves. Now I want you to manipulate it the other direction. You gotta be able to do this without a calculator. First of all, you gotta show your work. I am not giving you credit on your homework assignments tomorrow if you don't show your work. Now, if I give you the square root of 16, you don't need to show me all that stuff. But this, I want to see your work. Alright, Luke, what do we do?
It's 20, the square root of of 25 to the negative third. Take the square root of 25 is 5 to the negative third.
Okay, hold on. So at this point, we're going to do 2 different ways. We're going to solve both ways. So what he's doing right at the moment is he's going to take the square root of 25, and then he'll take it to the negative 3, based on what he said.
That way it seems a lot simpler.
Okay? Or you could go ahead and do the square root and figure out what 25 to the third negative 3 is first, and then take the square root of it. So I'm going to do it both ways. Cool. And you get to choose whenever you're doing these problems which way is easier. Maybe you do it the long way first and you're like, oh, I should have done it the other way. Sometimes they're both long, okay? So this way, we'll do it the way Luke did it first. The square root of 25 is 5, and you're raising that to the negative 3. Luke?
1/5 to the cube, 1/5 cube.
Which is?
125.
Alright, so that's what we should get over here. Okay? So now, inside the square root, I have 1 over 25 to the third. Is that correct? What is 25 to the third on your calculators?
125.
25 times 25 times 25?
Oh.
It's 100 or 15,625.
Alright, so that's 1 over that, and now I'm going to take the square root. So, with our square root rule, obviously this one was better.
Yeah.
Okay, so with our square root rules, you got to take the square root of the top and the square root of the bottom. Square root of 1 is 1, and the square root of 15,625.
Oh.
125.
Oh my goodness,
Oh, yeah.
math works.
I got
That was
0.008.
Yeah.
What do we use the 2 for?
That's technically it.
Yeah.
This is telling you what number you multiply by itself 2 times to get the number inside. So 5 was the answer here, because 5 times 5 is 25. 125 times 125 gives me the square, excuse me, that's the root of 15,625.
Wait, what did you do? You took the square root?
Okay, like a cube root. Hold on a second. This is kind of off the... What is that, Lynn? This means, stop.
I'm just guessing.
This means what number multiplied by itself 3 times equals 8. So the answer to this is 2, not 2 times 2 times 2. Okay. So this number is asking this right here.
Okay.
Got it? Alright, so if I said the 4th root of 16, what do you think that is?
2.
Yeah. Okay.
Is there any way to do that other than plumbing check?
Intuition. I mean, I think after you do this and after you do it in Algebra 2, because in Algebra 2 they get a lot more difficult. Or I shouldn't say more difficult, it's the same thing, it's just you have lots of letters and fractions. by then I think this will be easy for you. Sophie?
Will there always be a 2 on the outside of the square root?
No. That's the outside of a square root, yeah, that's what the square comes from. So her question is this right here. That should answer your question. Sophie, rewrite it for me, like this. Tell me what to write.
The square root symbol, hang on. The square root symbol with
Radical.
the 81 in it. And on the outside, and
Here? Or here?
right
Left or
there,
right- left
right
or
there,
Left or right?
right,
Okay, what goes here?
4
Okay, again, it can go inside or it can go outside. Where's the 3 go?
on the outside
Where?
of
Left
the
or right?
left.
Alright, so there, it's not a square root sign anymore.
The outside should be 3.
Oh, sorry.
Yeah. I was about to say,
Yes.
Matt, make sure you have this in
I
front
have
of you.
that.
Okay? Yeah, the top number goes on as the exponent. And the bottom number is always what goes on the radical. Okay? Now let's do this. I'm going to do it two different ways just to show you that, depending on how you do it, one way might be a little easier than the other. So we're going to take the 4th root of 81, and then we're going to cube it. So somebody on your calculator, you should be able to do that. You should have, some of you have I think it's a y here, and an x here, or I don't know which one it is. You should be able to put in the number first, like 4, hit this key, 81.
Oh, goodness.
You should be able to. Is that what you guys did? Those of you who have the calculator?
that's
Okay.
3.
It's 3. Yep.
So the 4th root of 81, 3 times 3 times 3 times 3 is 9, times 3 is 27, times 3 is. I'll let you all figure out the calculator real quick. So this is 3, and then 3 cubed is.
27.
All right. So the other way, we better get 27. Okay. Are we all caught up on it? What are you guys? You good?
Yeah.
That's important that you can use your calculators. But let's go ahead and cube 81. What is 81 cubed on your calculator? Everybody should know how to do that.
531,441.
Is that right? 81 cubed, 81 times 81 times 81.
Yeah.
All right, so now take the 4th root of this number.
Oh boy.
Okay, first of all, you should have been able to tell me what the 4th root of 81 was without your calculator. But again, you're not used to using these numbers.
27.
Really?
Yeah, that's what I got.
Amazing.
Well, I got 27.
I'm sorry.
I got 27. Wow, you're still.
Okay, listen up.
What?
This is really kind of getting into algebra 2. I'll go ahead and do one with you.
Yeah.
I'm going to make one up here. Example 4. Let's see. How about okay, now I'm guessing here. This, guys, this is really going to kind of, we're progressing here, stepping a little bit into algebra 2, but I'll just go ahead and show you. Whenever you take the root of a variable, you got to remember how you got that exponent to begin with. How do you get exponents on variables when you multiply them together? What do you do when you multiply like bases?
You add.
Yeah, isn't that what you're doing? What this is asking? What are you multiplying together? What same thing are you multiplying together 3 times to get that? Okay, well, if I multiply x 3 times, do I get x cubed? Right?
Yeah.
Okay, watch. This is really a puzzle. You asked for it,
Who else?
Cameron.
Cameron.
Isn't x cubed the same as x to the first? Or x cubed times x to the 1 the same as x to the 4th.
Oh, yeah.
Yes.
Okay. With my radical rules, I can do this, can't I? Right? Isn't this the same as that?
Yeah.
Yeah.
We've not,
Yes,
you better be saying, yeah, I've already taught you that you can do that. Okay, you can split multiplication apart in radicals. Well, the cube root of x cubed is what? Glenn, what did I say over here? The cube root of 8 was 2 times 2 times 2. Isn't that 2 cubed?
X.
Okay, so isn't that x cubed the same as x times x times x?
Yes.
Okay, well isn't that, and what was my answer to this? It was one of those, right? Well, that's the point. The cube root of x cubed is just going to be x. And you're left with x, cube root of x to the first. That's actually what you're going to do when you get down to 2.
Oh, Lord.
You're not ready for it yet. Some of you can do it, but I mean, it's not that difficult. Yeah.
Okay, the thing about that, on my calculator, it says that is the same thing as square root of the square root of 531 or 1.
Okay.
So, like, does that make sense?
Oh,
Because of the 4.
Okay.
Because I took the square root of
All
that.
right, let me give you the assignment. I'm going to write what you just said on the board to show you why it works.
Okay.
If I'm understanding you properly. The assignment, guys. Ready?
Oh, boy.
Page 510. Guess what?
1 to 12.
1 to 12.
Yeah.
That was easy.